Hello boys and girls, this is Mr. Kizik, and in this video we're going to be looking at some word problem applications for law of sines and law of cosines. So with these problems here, again, you won't be told which law to use. Based off of how you draw the picture and what's given to you will determine what you are to use. So for number 6, it says you've got a wire that's 30 inches long, is bent into a triangle with sides measuring 6, 11, and 13. And we want to find the measure of the largest angle of this triangle here. So the beginning part there essentially really was not needed, but so we got a triangle. Measures, we'll say 6, 11, 13. Doesn't matter if I draw it as 6 on top and then 11, 13, that part doesn't matter. So now we want to find the measure or the largest angle in this triangle. So if you recall from last class, when you guys did the example problem, the largest angle is opposite the largest side of my triangle. So 13 is my largest side, therefore my largest angle is right here. So with the given information that I had here, which law would I use? Well, I was given 3 sides, so therefore the law that I could only use is the law of cosines. So my setup would be what's called the angle we're trying to find x. So remember, it's opposites. So what's the side opposite of the angle I'm trying to find? It's 13. So it's going to be 13 squared equals 6 squared plus 11 squared minus 2 times 6 times 11 times cosine of x. Now this problem here, yes, we would have to actually do the algebra. So 13 squared is 169 equals 36 plus 121 times 2 times 6 times 11, which is 132 cosine x. I can combine 36 and 121, and I get 157 minus 132 cosine x. I can subtract 157 from both sides, and I would get 12. 12 equals negative 132 cosine x. And then I would divide everything by negative 132, so let me actually do it on the left side here. So I'd have cosine x equals 12 divided by negative 132, which then means I have to do the inverse cosine of this here. Negative 132. And when I do that, let me just do it in a calculator here. Negative cosine of 12 divided by negative 132. It's going to be roughly around 95.2 degrees. All right. So the hardest thing really here is to make sure that you're labeling your pictures correctly so that you do have everything in the right place and you're able to use the right law. So if I look at number 7, we got Tia and Braden are standing 12 feet apart from each other on opposite sides of an in-ground swimming pool. So essentially what's happening here, they're in the swimming pool. So here they are. Here. Braden. And they're 12 feet apart. 12 feet. In fact, because of the way the rest of the problem is going to go, let me draw it a little bit differently. All right, so they're 12 feet apart. They spot a pair of goggles on the floor between them and the angle of depression. So we'll review from when we talked about angle of depression. The angle of depression from T and Braden to the goggles is 65 and 28 degrees respectively. Remember, angle of depression is the measure between looking straight ahead and then looking down at an object here. So when I do that, so Tia will say is 65 over here, and then Braden is 28 over here. So let's just label it T and B. And then we would say, okay, so it wants us to find what is the distance from the goggles to Tia directly. So Tia is right here. So we're trying to find this distance right here. Now again, we're going to look to see what was given to us, and what was given to us were two angles and a side. based off what we learned last class, this would be law of sines. So to do that, my setup would be, I think I'd have more, I'll set up over here and do the work on the other side. It would be sine, well, first let's look at it here. We would have sine of 28 over x, that's what we're trying to find, that is equal to, but if I look here, there's nothing opposite of the 65 degrees. That's where, remembering if I have two angles in my triangle, I can still figure out the third angle here. So I have to figure out this third angle right here down below in order to use the 12. So I would take 65 and 28, add that together and subtract it from 180, and I would get 87. So equals sine of 87 over 12. And now I can do the whole cross multiplying. So I would have 12 sine of 28 equals sine x sine of 87. And then I divide each side by sine of 87. So on my calculator, I would just plug in x is going to be equal to 12 sine of 28 divided by sine of 87. And I would get that is roughly, x is roughly 5.6 feet away the goggles are from Tia. All right. The next, number 8 here. So it says starting from the same port, which just means it's starting from the same place. Ship A and ship B sail apart with a 30-degree angle between them. So let's pretend the port, right here. Whatever the opening you want to call it. We got ship A. Here's A. Ship B. Let's erase this here. They traveled out 30 degrees between them. Okay. Ship A traveled 5 miles. Ship B traveled 8 miles. And we want to find the distance between the two ships, so we want to try to find that right there. So in this case, we're given two sides and an angle, and we need to figure out which, because remember, both law of sines and law of cosines deal with two sides and an angle. So take a moment here, and what do you think? Am I going to use law of sines and law of cosines? Well, if I was to use the law of sines, I would need to have another angle opposite of the 8 or opposite of the 5, and unfortunately I'm not able to figure that out, unlike number 7. So I would have to use the law of cosines here to figure out the missing side. So I would have x squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 30. And now I could just plug this into the calculator with the square root. So we do that here. Square root of 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 30. Taking out the parentheses there. And I would get that they're roughly around 4.4 miles away. All right. So that, ladies and gentlemen, is how you would apply these problems to the law of sines and law of cosines. Hardest thing basically is to draw it out and figure out where everything is. So on that note, what I would like you to do for homework is I would like you to do numbers 6, 7, 8, and 9. Again, if you have any questions or concerns, please feel free to message me or come see me. This is Mr. Kiesik, signing off.